Welcome to Section 2, Building a Larger Application. In this section, we will look at the built-in input and output widgets that make it simple to build applications with Shiny. We will also look at animating graphics, producing attractive and powerful data tables, downloading and uploading data, and controlling graphics within a Shiny application. This is the first video in this section, Shiny Building Blocks Part 1. In this and the following video, we will spend some time looking at the different widgets that can be used to get data into and out of your application. There are a wide variety of input and output formats: dates, numbers, text, graphs and tables, amongst others, and we will review all of the basic types in these two videos. In this video, we will look at two of the three basic types of output in Shiny applications: graphs and tables. We will look also at the tab set panel layout function, which can be used to keep your outputs separate from each other. Before we look at the output, which are all defined in the server.r file, let's recap by looking again at the structure of the server.r file itself. At the top of the file go all the functions which do not need to be reactive, that is, do not need to change when inputs change. This includes package loads and data functions. Reactive functions are contained within the function brackets input, output, curly brackets instruction. Each output widget is given a name and referred to by output $name. The output widget is given the value of renderPlot, renderTable, or renderText, if we just consider the basic output functions. Each of those functions, in turn, contains an expression that returns either a plot, text, or a table. We will talk in detail about the type of return each should make when we look at these functions in a moment. This application will make use of tab set panel to keep the output widgets organized. We have seen this function in the previous section, but let's take a quick look at the code. We're using the typical sidebar panel setup. As you can see, I've deleted the inputs defined in the sidebar to save space on the slide, and within the main panel we have the tab set panel defined. Within the tab set panel function there are as many tab panels defined as you need for your application. Each tab panel defines a title and then as many output elements as you want. This is a very simple setup with one output widget per tab, but you can have as many input and output elements on a tab as you wish. We will see a more involved tab panel setup in the main application in the next video when we look at the input widgets and the UI.r file. So without further ado, let's take a look at the plotting widget function, renderPlot. Here is the plotting function for this application, and here it is in action. The code generates random data between two dates and plots a line of trend on top of it. The user can select the date range, like this, the shape of the function, whether it's linear or square, and the type of trend, Loess or linear model. Here is the code that defines the plot. It's fairly typical of a Shiny plotting instruction. First comes the renderPlot function, which defines a reactive plot. Note that the expression which returns the plot is wrapped in curly brackets, as is usual. As you can see, there are a set of data instructions. In a real application, these are likely to manipulate the data in response to inputs rather than generate it. And then ggplot is used to plot the data. Note that there is no need to explicitly use the print function to draw plots, ggplots, or base plots, or any other kind of plot, and indeed it is unwise to do so in the case of ggplot, because it can interfere with interactivity if you go on to use interactive graphics. If you do assign a ggplot to a variable, which you may do in the case of a complicated plotting expression, simply use the return function to return the variable rather than using print, as I have done here. It is strongly recommended here and everywhere to write your code outside of a Shiny application first to make sure that it is working, particularly when you are learning. Very often you can waste time debugging reactive inputs and other Shiny elements when in fact you have a basic error in your plotting instruction. Note the dependence on three inputs within this function: box input, pick radio. These elements control the shape of the graph, the smoothing function, and the title, respectively. Their structure and content will be discussed in the next video. Now let's look at the table. The table is designed to be useful when you're learning Shiny, and it shows the return values and class of each of the input elements defined in the application. I've added some basic interactivity, allowing you to select the numbers of rows to view and the columns to show. Let's look at the code. Again, we give the output a name, in this case table display, and the output is wrapped in a renderTable function. RenderTable, like renderPlot, accepts an expression which we wrap in curly brackets as before. The expression must be something which the xtable package accepts. There are many possible things that you can pass to xtable, but in practice Unless you are reporting statistical tests, you are likely to use either a data frame, a table, or a matrix. For more on each, type $data frame, $table, or $matrix at the console. As you can see, the return instruction subsets the data frame by number of rows, using the numeric value which input slider returns, and the set of strings which input check group returns. These values come from slider input and checkbox group input respectively. These functions will be shown in the next video.